Okay, October 20th, 2011. This is a quick review of lesson 3.2. They want us to factor this. So right now this is in standard form. We need to get it into our factored form. So, in other words, we need to factor our quadratic expression. To find the factors of this, I take the factors of a, our first term, and our last term. Move it all down. We take the factors of our c term, the last one, so 1 and 20, 2 and 10, 4 and 5. And we need to get to -9. Okay, so when we try multiplying all these columns out, we know that 1 and 20 aren't going to work. 2 and 10 won't work. But 4 and 5 will work. Now, in order for that combination to work, I need 4 and 5 to both be negative. Since that's the case, they're both negative. When I go to put them in to our factored form, we get 1x, 1x. First terms are the same. If the first terms are the same, it doesn't matter where we put the second term. So our second terms, -4 and -5. No, it's fine. Now, I need to graph this. So the first thing I'm going to do is I need to find the X intercepts. So I'm going to change f at x into y. They're both the exact same thing. And in order to find an X intercept, I'm going to be looking for our x value, and I know my y value is 0 for an X intercept. So I'm going to plug 0 in for y. We get x minus 4, x minus 5. We're going to split the equations. So we have 2 now. 0 is equal to x minus 4. 0 is equal to x minus 5. X is 4. And x is 5. Okay? So, I'm going to keep going. That means our X intercepts, one of them is at 4 and 0, and the other one's at 5 and 0. Yes, Sam. So, I need to graph this. We put our graph up. We plot our 2 points. One's at 4. One is at 5. I have my 2 X intercepts, but I still need to find the vertex. The X value of the vertex, R plus S divided by 2. We knew R was 4, S was 5. We plugged them in to find our X. So we get 4 plus 5 divided by 2 becomes 9 divided by 2, which is 4.5. So there's our axis of symmetry. The equation
what is R and S stand for?
of the axis of symmetry, those are the zeros.
Symmetry. Yeah, symmetry.
So would it have mattered if you made the R5 and the X4?
Sorry?
Would it have mattered if you made the R5 and the X4?
No, it wouldn't matter. Our axis of symmetry goes down right in between. That's not perfectly drawn. Oh, 2 S's. So the equation is x is equal to 4.5. Now I need to find the other coordinate of the vertex. We have the x value, which is 4.5. I'm looking for the y value. So I take my x value and I plug it into either the standard or factored form of our equation. Okay, I'm going to choose the factored form. Our factored form was y was equal to x minus 4, x minus 5. We're going to plug that value in for both of the x values. 4.5 subtract 4. 4.5 subtract 5. So we get 0.5 and negative 0.5. When you multiply them together, you get negative 0.25. So our vertex is at negative 0.25. Oh, sorry. 4.5 and negative 4. When I go to plot it, my negative 0.25 is going to be roughly there. And finally, the last thing I should know is a Y-intercept. Y-intercept is the same idea as the X. The only difference is we are looking for our Y value, and we know our X value will be 0. So I take our standard form of the equation, which was f at x was equal to x squared minus 9x plus 20. I plug 0 in.
That's the equation.
Give me 1 sec, Sam. So 0 squared is 0. 9 times 0 is 0. So our Y-intercept is at 0 and 20. So if we go to our graph, we go to graph this, our Y-intercept would be way up here on the graph. Okay? This graph only goes to 10, but our Y-intercept would be at 0 and 20. So I'd have all my coordinates. Y-intercept.
So are you giving us the graph?
Yeah. 2 X intercepts and the vertex.
So you don't
So to find the Y-intercept, that means the Y-intercept is always going to be X value of 0, and we're going to be solving for Y. So what that means is I'm going to plug the number 0 in for X in both of these.
Oh, there you go, Sam. Got it wrong.
Junior. In standard form, usually what happens is it's going to be the last number will be your Y-intercept. So in this case, 0 squared 0, 10 times 0 is 0, plus 16. Our Y value is 16. So the Y-intercept for the very first graph
Would you look at that?
was 0 and 16.
Shut up!
Oh!
So on your graph, I know I didn't have it all the way up there. I was hoping you guys would estimate where it would roughly be. So that was going to be our Y-intercept. The next thing it asked you was the X intercepts. X intercepts, we need to go into factored form. Okay? So we take our standard form and we factor it. Take the factors of the first terms and the factors of the last terms. And it's got to add up to negative 10. So I'm going to tell you from doing this, it's going to be 2 and 8. And they both need to be negative. So when we multiply 1 by 2, we get 2. 1 by 8, we get 8. And in order for them to create negative 10, we need both of these terms to be negative.
Wow, are you serious?
No, I got it right. I'm saying that's a different one.
So because the first terms are both 1, it doesn't matter which bracket I'm going to be putting the second terms into. So I'm going to put negative 2 and 1. negative 8 in the other. From factored form, same idea as our Y-intercept, our X intercepts, our Y value has to be 0. So what that means is I'm going to substitute 0 in for Y. And then I'm going to solve these two equations. In order to solve them, I set each of them equal to 0. So I split it into 2. I have 0 is equal to x minus 2. 0 is equal to x minus 8. 2 equals 8. Sorry, 2 equals x. 2 is not equal 8. And 8 equals x. So our two x-intercepts are at 2 and 8.
Got that right, Seth?
From there, we got to find the equation of the axis of symmetry. I need to use our formula to find the x value or the axis of symmetry. So our axis of symmetry, or AOF, is r plus s divided by 2. Oh yeah, why did I put f?
Get out of here, man. I'll give you a ball.
So we plug in 8 and 2 for r and s. So 8 plus 2 divided by 2, 5. So our axis of symmetry was at 5. Or in other words, x is equal to 5. So we have a straight line going up there. Our equation is x equals 5. And the last thing we have to do is find the y value of the vertex, because the axis of symmetry gives us the x value. We have to find the y value. So I take my 5 and I plug it into either the factored form or the standard form. I'm going to use the factored form. X is equal to 5, so I'm going to plug 5 in for both of the x values. Oh, that shouldn't be plus. Junior, he's right. Be quiet. So our vertex is at 5 and negative 9. So once we have all these points, 5 and negative 9,
Oh, you are.
we connect the dots.